I'm Justin Barone, principal architect here at Promevo. So we have a customer that wanted to move their API to the cloud. As you can see on the left, they were in another cloud in the East Coast. They had an Ubuntu VM. They had to deal with a lot of issues when it came to updating as far as pushing releases to their VM, dealing with scaling and whatnot. It was actually a really simple architecture here. It was just running an Express.js REST API. They were probably doing about 10 requests a second. They supported a total of 100,000 users. That doesn't mean there were 100,000 users using this system at the same time, but their front end used this API for basically all communication between the database for reads and writes. They were planning and anticipating growing up to 1 million users that they needed to support. And they thought, okay, maybe we're going to hit 100, 150, 200 requests a second. And right now with what they had, they were like, oh, this is way too hard to deal with. Their DB was a medium-sized Mongo Atlas. It was a replicated cluster deployed over in GCP. So it was purchased through Mongo Atlas. Everything was done there. But when you deploy out a cluster in Mongo Atlas, you can choose to deploy it out to various clouds. Theirs was out in GCP. And the significance there is going to be important here in a little bit when I talk through some of the money that we've kind of saved them. Access to Mongo was over the public internet with whitelisting. So one thing I always see as sort of a red flag and kind of worries me a little bit is if the database, even though you're doing whitelisting of IPs, is still available public to the internet. Some other things to note here on the API server, they were running a single Ubuntu VM. Internal to the server, they had Nginx running as a proxy and a load balancer. They had multiple instances of their node server running using systemd. The fear here is that if this VM dies, their entire application goes down. If we were to think prior to Docker or prior to containerization, you would have maybe had the Nginx server as its own server, its own VM. You would have had multiple node VMs where you had instances of node running on them. And then you could scale up VMs and scale down VMs and things like that. This wasn't that scenario. This was done for kind of performance reasons. They weren't using Docker. There was no PM2 to manage their node server or anything like that. The other thing I want to point out too is in a situation where they had failures with their server, their only option was really recovery and restore from a backup. They could have downtimes of 15, 20, 30 minutes if they even just restored right away. They definitely outgrown what was a very early production architecture, right? I could see early on when they barely had any traffic, they're like, hey, this will work. But they kind of outgrew that. And they got to this point where they were really nervous and frustrated. App deployment, when they would deploy their app out to the server, they would take their build, they'd run it, they'd zip it up and then push it up to the server into a location. Then they would SSH into the server, expand out the zip into a directory, and then restart all the instances one by one. One of the things I like to always point out, when people are the ones doing different steps of a deployment, of any kind of management of a server, that just screams human error, right? We're humans, we're not computers. We don't perfectly execute every operation. Maybe the person whose job was to deploy was tired that day and they miss a step, right? Whenever that kind of happens, you fall into some traps. Another thing I want to point out, scaling here was vertical. They were like, oh, we're hitting our peak, we're maxing out our CPU, our memory. They were just giving it the next size up VM. And they weren't really scaling down until they were in off season. So what would happen is they'd be burning money in parts of either the day or parts of the year even or month where they had very little traffic. And then, they're paying for this big expensive VM and their CPU's running at like 0.5% usage. They had to, one of the other things, right? When you got a VM, you're on the hook for managing the OS, for making sure there's security update, installing packages, making sure the packages are all updated. So really, this is sort of like last gen way that you would run server systems. Deployments took upwards of 2 to 3 hours because they would deploy, they would run tests, they would verify. Sometimes they'd have to roll back. 2 hours, 1 hour, maybe 1 hour if they were like lucky and it was a real simple deploy. But they tend to spend a long time deploying and validating that, hey, this next version of their API, right, is good. And the reason why I brought up why it matters that they were in GCP is that they were paying a lot lot of money in egress every month. With cloud, with really anywhere where you're in a data center, anywhere where you're sending data out from the server, the data you're paying for that, and that's considered egress. From their MongoDB data transfer, they were spending 12.5 cents a gig. That was considered an external IP, and it was a Google Cloud to the public internet egress. That's kind of the most money you can spend on egress. Then from their front end server, they were spending 9 cents a gig. And so if you put that together, they were spending around 21.5 cents a gig. And that might not seem bad if you're doing 10 gigs a month. When you're pushing hundreds of terabytes of egress a month, that starts to add up big time. So what was our solution? First thing, we knew we could set up a peering connection between MongoDB Atlas and a Google Cloud VPC. So they were in some other cloud. And we were like, okay, first thing we can do is if we get them into GCP and have them running out of the same region, then we can save some money there. And then the other thing about that as well is the privacy. Now their database isn't going to be exposed publicly to the internet. It's going to be on a VPC, effectively in its own internal network or subnet, and not accessible via the outside world, which is very important for hacking and security and what have you. Next, we had to decide where the application would run. There's this really great page over at Google Cloud, and feel free to snap a shot of that QR code and head over there and check this out. This is a really great page that shows you options for where you want to host things. On the right, you have cloud functions. On the left, you have your VM. And the way I think of it is if you go from right to left, you're going from more agile to more configurable. So when you go serverless, you're much more agile because you're just focused on writing your app code, pushing your app code. You're dealing with your application. Your devs can like fully focus on making your users and your customers happy. When you go to VMs, you get way more configurability, and you may need that for your application, but there's much more maintenance involved, keeping the operating system up to date, keeping security patches in place. The way I always try and look at things, how can I go as serverless or as agile as possible when I'm scaling out a solution? So the solution, we Dockerized and migrated them to Cloud Run. So we took their Node API, we Dockerized it, we built a CI/CD pipeline in GitLab for deployment and containerization. They were working out of GitLab as their source control repository. Remember before there was this whole process of I'm going to do the build, I'm going to zip it up, I'm going to transfer it up to the server, then I'm going to log into the server, and I'm going to do all this stuff. Well, what they have now with a good CI/CD setup is they deploy based off of merges and branching and tagging. They can give a specific tag and a specific branch and merge into that. And what it does is it deploys out to either their production environment or their test environment, their beta environment, what have you. So it's really cool. So as a developer, I can just do my work, push it up, get all my code reviews, get all our testing and stuff done. And then our merge manager can go ahead and schedule it up, merge it into the correct branch, and away it goes. The beauty of this is it takes that code, it runs it through Cloud Build. So it runs a build and it creates a Docker image. It then pushes that image to Artifact Registry. Cloud Run picks that up, and because there's some code in there that handles transferring over to the new version, it's called traffic splitting, and we use that. And what happens is when they do a deploy, within a few minutes, their stuff's out there and live. And, it's a really great setup. Additional to that, we create a Cloud Run service. So that service that their app is running on that REST API, where that Docker container is running, it's Cloud Run. We protected it by using Cloud Armor and a global load balancer. I didn't show that here just for lack of space, but some of the great stuff out there that Google Cloud has for just security, right? Security first and just thinking from that standpoint. Their database solution stayed exactly the same. So that's kind of the beauty here. They had this very large database, many terabytes of data. And, all we had to do was we created a VPC peering connection between Mongo Atlas and their client VPC. So we effectively created this connection directly from where their database was being hosted in a VPC that was controlled and managed by Mongo Atlas, but it was within the same region. So now their transfer costs their egress went from, what I say was 12.5 cents to 1 cent per gig. So now it was considered an internal IP zone to zone egress in the same region. So that's really significant right there, right? And then based on the amount of data that they pushed out of the system, their public internet egress from their Cloud Run instance out to the public was about 4.5 cents. So we brought them down to about 5.5 cents per gig, and that's about a 75% reduction in data transfer, which is really awesome, right? Some ROI right there. In addition, we use some like really cool features of Google Cloud, right? Like I talked about Cloud Armor, I talked about the load balancer. We also use Secret Manager. So Secret Manager plus some environment variables. So any of those configuration settings, any secrets like API keys, keys for talking to other REST APIs, some third-party APIs, the keys for talking to the database, all those were kept in Secret Manager and injected into the Cloud Run instance when it fires up, and then the application just picks it up and reads it as it utilizing it. So really smart way to do security there. Then, when we deployed this out, one of the things I wanted to kind of talk about was how we tuned Cloud Run. Cloud Run allows you to take a container, push it out, have it run as a service, and then it'll scale on demand. It'll scale up, it'll scale down, and there's some things you have to do there to make sure that your application's scaling correctly. So you'd set your min and your max instances. They wanted to be able to start from 0 instances. And so if you set that at 0, your application has to be able to start up very fast. So that was some things where we had to do some tweaks to their application to just make sure it starts up quick. You mess with the memory, like how much memory do you want to be able to give us? We had to increase memory because we were doing some PDF generation in one of the APIs. And then you also set how many concurrent requests you want. So it's kind of across all those different variables, you can determine how it scales up or down. As we were testing the system out, whether it was in the beta environment or when we went to production, we would monitor peak times and then sort of tune according to how we wanted it to scale and sort of that curve. I always try and set it up to where from a memory and CPU standpoint, I keep it at about 85% of memory and CPU. It gives it a little overhead for bursting, but it's kind of using as much as it can. They're now doing fully automated deployments. I talked about before how whenever they needed to scale because say they were running into issues and running out of memory or CPU, they were having to spend a lot of time and it was very stressful. Now that all happens automatic. This is like the beauty of Cloud Run. If anything that you can take away from that is the on-demand, the scaling, and being able to work in your CI/CD process into this is awesome. So the customer could actually focus on app development instead of stressing over scaling. And then lastly, I just want to quickly go through the kind of benefit they got from this, right? So beforehand, they were peaking at around 10 requests a second. It was very painful. Everything was manual, deploys, scaling. There was too much human interaction, chances for things to fall apart, big egress costs, big server costs, wasted server costs. Their DB, even though it was whitelisted to an IP address, it was also open to the public internet. 2 to 3 hours to test and deploy. Deployments required a maintenance window. They had a 22% deployment failure rate, a lot of human error, no monitoring, alerting, or metrics, zero redundancy, and their scaling during peak season was a nightmare and had everyone stressed out. So what did they end up at? They grew to 100 requests a second, no intervention. In fact, I talked with the client recently and they said, hey, we don't even have to touch it. We just worry about pushing updates and working on the application. The infrastructure is great. It scales up and down as expected, and they never have to worry about it. They now have a CI/CD deployment process. They saved 75% on their egress. Their database is more secure, right? Because now it runs in a private network. Dynamically, they can scale from 0. They have faster, more consistent performance because now they're running internally on the GCP premium network. CI/CD and tests. This is the biggest thing right here. Their deploy is less than 4 minutes. That 2 to 3 hour deployment time is now 4 minutes. This is amazing. Their only bottleneck is running their automated tests and their Docker build. No more maintenance windows. They can deploy multiple times a day. Thank you to traffic splitting. I mean, they could deploy 100 times a day. It wouldn't matter. And this is kind of the beauty of going to Cloud Run, going to serverless, is that they have an entire pipeline and they can do on-demand deploys. This is great. They have a 1% still deployment failure rate, but that's human error, right? tests are failing, this or that happens, right? That's still going to happen. You kind of can't get away from some of those things, but because of traffic splitting, the customers don't see that failure, and because of they have a really robust beta environment and test environment. So their ROI, they achieved 98% reduction in deployment time, 95% decrease in failure rate. And so their like total efficiency gain was like 97%. And then my favorite part, their DevOps had a satisfaction of 100%. They went from wanting to pull their hair out and being really freaked out all the time whenever they had to deploy updates, deploy anything, to they're loving it. Again, if you need any help from us setting this up, please hit us up.